The other notes in my hand, compare answers 1 through 3. Well, 3 would have been nice if these were both pi over 3's. Cosine of pi over 3 is 1/2, and then we would have got 1. So when you switch the angles, that doesn't, end up being an identity. And as I said to you guys, you've already seen this identity. You had to use them on yesterday's quiz if you took it. And they were just given to you. Now you have to have them memorized. So I'll go through the memorization of that again. But the identity was cosine squared theta plus sine squared theta equals 1. This is just demonstrating whatever I throw in for theta, I will get 1 no matter what when I evaluate. And then another one. Look at 2. Look at 4, 5, 6, and 7. What do you notice? 4, 5. That's just denoting that the rule for tangent is tangent equals sine over cosine, because I get the same ratios when I evaluate, as long as you evaluated correctly. All right. Then 6, 7, sine over cosine is undefined for 11 pi, or pi over 2. Did they change that to pi over 2 on your sheet, right? Okay, so sometimes we change the key, then just, or change the worksheet, but then just kind of overwrite the key. Same thing, 6 and 7, sine over cosine equals tan. You get the same evaluation. And then this is some other Pythagorean identities, if you got this far. So 8, 9 are equal. That proves the identity 1 plus tangent squared equals secant squared. And then the last one, 1 plus cotangent squared equals cosecant squared. All right. And then we didn't get a chance to turn it over, but look at your graphs. And that was just to show these even odd identities. So I'm actually just going to go to it. Put at your bottom of your notes, rewriting these, and then I'll derive the Pythagorean identities in a moment. So when you look at the back, the graphs of that sheet that I gave you as a, sorry, I guess if we're doing the video, we're looking at this. There's graphs on the back. And I did call those the even odd identities. I did actually show you this. I showed you why these are also called the even odd identities. But what you have to remember, now go ahead and write. Well, let's go in order. First of all, reciprocal identities, there they are. The even odd identities, sine is odd, all right? And I did show that when we did these notes, when we first introduced these to use them to solve equations, right? So I wish we could have done it as input output. I could have asked you sine of negative 30 and sine of 30, and then see that they're opposites. So that's why I need a negative there. But what's interesting about cosine of negative 30, which is, that's in quadrant 4. So that's positive root 3 over 2. And cosine of 30 is positive root 3 over 2. So for cosine being an even function, you get the same result. So talking about the even odd identities on, which are called negative angle identities as well, this first or second row. All right, gonna move this, and then I'm gonna go and prove these Why do I prove these Pythagorean identities? In case you forget them. So I've done this with you once. This is time 2. And I'm gonna do it a little fast track. The first way I did this, I went through all of the order of operations when I don't know if it's called order of operations, but simplification operations. When I decide, I'll make that a capital R, when I decide to divide by R squared. And I broke down x over R squared, or x squared over R squared, is x over R squared. Then I drew a triangle off to the right, and I said this is the triangle x, y, R, right back to the origin. And then theta is some magical angle, all right? What's x over R of that magical angle? Defined by cosine. So this is cosine squared. And I think we should be able to do this. This is cosine squared. Y over R. What's y over R, everyone? Sine squared. And then what's R squared over R squared? 1. And we should be able to do this quick. All right. And then you know what you do quickly? Fine, I'm done with that. Then I'm going to change colors. Now I'm going to divide by y squared. Why? Because now I can get a different identity. What's x over y? Maybe I made that a little too hard. What's x over y? It's not y over x. That's cotan. So this one, when I divide by y squared, I get cotan. Y over y squared is 1. And then what's r over y? The flip of y over r. It's cosecant squared. So this is the other Pythagorean identity, or the second one, not the other, because there's a third. If I divide by x squared, doesn't matter where you put it. Okay? X over x squared, both of them being squared. Y over x is tan. And then r over x is secant squared. Now here's where this gets weird. Not weird. What you also have to be aware of is alternate versions of this. Now I could play with this forever, but if I subtracted sine squared from both sides, this is what you had to figure out on your quiz. All right? Not really. We talked about this. So you have to be ready for alternative forms. That's a sine squared. Sorry. Looks like a sine 2 theta. Let's get rid of that. And then cotangent, like this. What's cotangent squared all by itself? Well, then that equals cosecant squared minus 1. I just have to subtract 1 from both sides. What's 1 equal? This is wild. I could actually turn these all into 1. Well, let's just turn this one into 1. That's equal to secant squared theta minus tangent squared theta. All right, you got to be ready for alternative forms just by subtraction or addition, manipulating the equation a little bit. And then there's those other ones that were proved, or not proved, kind of like verified with some angle measures on your first little worksheet there. All right, so keep holes in that worksheet. That wasn't homework. That was just to kind of think about these identities. And then there are these, right? And then that's why I gave you the not so great speech about what happened on our last test. It's not going to get easier. Those that don't do your homework and don't do your stuff, you are going to get destroyed in this section. Just prepare for it, all right? And I've talked about it forever. We're almost in March. It's like some of you, I think I'm talking to a wall, all right? I don't know, but just don't expect it to get better if you don't practice this, all right? So the word is simplify. You know what the main word is, though? Another word. Everyone say that word up at the top. Substitution. What? And only one person said it. It's all the rest of you, right? Substitution. Could you read that? See that up there, right? All right, anyway. So this is what you're going to do. And that's what simplify means. You make things larger, smaller, right? Isn't that what simplifying usually does? We want to make it less. So the only way we can do that is by substituting these things that are equal, all right? And then that's what's the best way to do this. Okay, and one of the best ways, and we're going to synthesize this over days, and it's going to get a little bit better. Today is the worst because you don't know where it ends. So you just have to try stuff, and hopefully you see that it gets smaller, like things cancel, and then that's what simplify means, and that should make sense to you. The best way, one of the best things to do is to change everything in terms of sine and cosine. So guys, look on the previous page real quick if you don't already know that. Cotangent is cosine over sine. So there's one substitution. Wait, Mr. Samuelus, you made that larger, not smaller. Well, look at the bottom. The bottom is 1 over sine. And again, just like in solving, you have to treat trig like variables. That's what we had to do for solving. We had to factor with trig, but then use the zero product property and use our unit circle. That's where it gets a little different. Here, you're not doing that. What you're doing is doing a substitution and then doing math. And I swear to dog, if you don't get this, I should kick you out of this class for a lack of listening. I've shown you a million times. Divided by 1 over sine is times sine over 1. Millions. And then knowing to cross cancel, nobody can argue that this is not simplified. I said that the way I wanted to. It might have been a double negative. I don't care. All right? That is smaller than what you started with, right? Wouldn't you agree that's less than what I had before? Yes, Mr. Samuelus. Let's move on. Okay, and you can't sit here and do nothing. You have to do something. So you got to make changes. When you see these little expressions that don't have much to them, then yes, it's the same thing. Change everything into the same variable. That means sine and cosine. Sorry. So you do something. this equals this. I don't even think I highlighted last year. Oh, I don't even need to highlight that. Sorry. My bad, dogs. All right, and then times cosine. You want to change that to 1 over secant. That's the other thing. People changing this to 1 over cosecant, this to 1 over secant, and then changing this to sine and cosine. You just created 4 variables. Does everyone make sense? Does that understand? So you do things that only help and can cancel. And the only way that you can do that is changing things that are in the same variables in case they cancel. Hey, and by the way, what is sine sine? What is sine times sine? And then look at what I think I literally wrote this one up there. What does 1 minus sine squared equal to? Cosine squared. And you must do that. That is no one can argue. You turn that into one thing. I'll tell you where it gets stupid. It's example 4, and we canceled it today. There. And actually, it was funny. They were discussing this today, and I go, oh my gosh, I looked at my notes last year, and I called this one stupid. Because it is stupid, and we ain't doing it. Kill it. Then you know what? In your homework, go to your homework right now. Let me see your homework sheet. All right, where's your homework? Homework. Kill 25 and 26. Destroy them. 24. What did I just say? Sorry. 25, 20. I just screwed it up again in my mind. 25 and 26. Because in my mind, this doesn't simplify when you're done. And yeah, you don't have to worry about it. We'll get better at these, will get easier as I move through the notes the next few days. All right, this is what you want to do on this one. Whenever you see squared, and you should probably be using a Pythagorean identity. Now, I don't want to make sine squared bigger. I want to make 1 plus tangent squared smaller. What does it say on the other side? 1 plus tangent squared equals secant squared. So yes, you're going to have to get this memorized. This is why I'm terrified of the students that have not memorized and dominated the unit circle yet. Because now you have more to memorize. And that's why I've been warning you, all right? You don't have the unit circle, it's going to get worse, and there's going to be more that's going to be piled on you. You need to get to those delta maths and figure out the unit circle if you still don't know it. Oh, I warned you. I warned you. I warned you. Now, why would I do this? What's sine over cosine? What is sine over cosine? Tangent. So look at this. You got a 1 plus tangent squared times sine squared. Look at what ends up happening. This is sine squared over cosine squared. This is an unnecessary step, by the way. You should know that this ends up being tangent squared. And I'm going to write this off to the side, and this would not have to be part of your writing. Because sine squared over cosine squared is the same as sine of x over cosine of x, all squared. It's just a notation thing. It's just like in these evaluations. What time do I? Yeah, we're doing good. And I guess I should have said this, but I have. We've had to evaluate. It was a walk around board when we had inequalities. How do I do sine squared of pi over 6? You sine it, then you square it. So that's what you see here. You see the sine of pi over 6, which is a half, then you square it. I wish I could write on this here, but that's what that means. Like when I see, I'm trying to hit this, I hit it 3 times and it didn't work. So when I see sine squared of pi over 6, it really just means what's the sine of pi over 6 and then square it. So I do have to cover this. This is mathematician laziness. So I don't have to write parentheses and extra symbols. That's exactly the word I was trying to get you to understand there. Then this turns into tan of x squared, and then that is written like this. We should not have to write any of this. We should understand that, right? I know this is the time to really kind of hammer that. So this would be your work, all right, in order to do this. This one's stupid because I disagree that it actually really simplifies. There's not really a simplified answer, and I think it would just confuse you. Hey, how do you add fractions? What do you need? Is this, how many more examples are there? Okay, we gotta go. All right, so what do we need? A what? Sorry? Common denominator. So what is that common denominator? Well, this one has a sine, but this one has a cosine, so what does this need? This needs a cosine. But to just introduce that, I got to multiply top and bottom by that. This is like, when we had rational functions in the first semester, and we had to get common denominators and add, and we did complex stuff. So anyway, I'm trying to reach into your brain. When did we do some side of operation like this? Some kind, sorry. And it was that one. Sine of theta, and then boom, boom. Okay, now, what's the point of getting a common denominator? This will all be under one common denominator. So anyone that asked me, how did this happen? You're missing the point. This is what happened in first semester with adding rational functions. It was the whole point of getting a common denominator. But in the numerator, we do have to clean up. Clean up. Everybody do their share. Anyone know who that is? Are you even too young for that? Barney the dinosaur? Anyone know Barney? Yeah. Okay. Thank you. All right, now, before I distribute this, hold on. I have a cotan. So have a little liberalness in your work that you can do 2 steps in one. And then remember what just happened in the last one. I want to get everything in the same variable. So what is cotan? What is cotan? Cosine over sine. And then you could take that sine and put it right next to it. And then you'll see what happens here. We could do that as part of this step. Then minus, and be careful if this is minus. I'll highlight that. If this is minus, that minus sign needs to be distributed into the numerator. It's not, but I'll say it one more time. Biggest mistake ever. Not distributing that minus sign if it's in front of that fraction and the numerator is more than one term. Yes, that's exactly what I wanted to say there. And then, sorry, I'm trying to fumble for my colors here. Minus, you know what? This is written as cosine sine. Multiplication's commutative. You know what? I'm going to do it. I'm going to mess with your brain. I'm going to write this as sine of theta, maybe. That n is destroyed. Cosine theta, and get you to understand that these are the same term. So I messed with you a little bit. Commutative. But one of them's minus, one of them's plus, so what can I do? Cancel them. Do it now. And then cancel these right now. Do it now. And now I look at it and I got, all right, what's cosine plus cosine, everyone? Not cosine squared. Sorry, whoever said that. It's 2 cosines. My bad, dog. This is why I never answer questions. Then I yell at you. It's okay. We make mistakes. I've made many. Hey, let's get married. No, I can't make that mistake. I can't make that joke. I forgot somebody's watching me. Anyway, now, trying to get me. Anyway, what is 1 over sine? What is 1 over sine? Cosecant. So we do want to maybe do that in the future. Just, maybe get it right at non-fraction form. So 2 over sine. Sine on the bottom becomes cosecant on the top because it's reciprocal. Is it a student? Okay. I don't have time for this. Oh, maybe one of these again?
Yeah. Again? Someone already.
No, is that?
Oh, yeah.
Keegan, are you here? I marked this yesterday. I did. I don't know why they don't this is part of my video too. We have a every day, sorry, no offense, but every day we get interrupted with Dean's office slips. It's okay. All right. What the heck was that? All right, anyway. Jesus. Or geez Louise. Oh, there we go again. It's just a friend in my neighborhood. He's never mind. Huh? What? Huh? Yes, ma'am. Jeez. All right. What do you want? I mean, sorry, go ahead. Was that cosine squared? No. I don't see a cosine squared anywhere. No, that's like 2x over x. 2x over x becomes 2. Yeah, it's not what you're thinking there. You're thinking like maybe exponents, you subtract them. No, the cosines cancel like variables. So 2 cosine over cosine becomes just 2. Just like 2x over x becomes 2. I mean, this is like this. Pretend sine is y. So 2x over xy would be 2 over y. That's why it's 2 over sine. Same thing. Remember, they're variables. Okay, now, too late. We're running out of time. So this is the factorization of this. Anyone? Difference of 2 squares. The variables are trig, or trig work like variables, so they factor like variables. Hey, and what do I do on the bottom? You guys are terrible at this kind of factoring. What kind is it? What kind of factoring is on the bottom? GCF. I don't know why people cannot see GCF as well as like the other types of factoring. And if you don't know what I'm writing right here, you don't know how to factor. He's so mean. I don't care. All right, now, I don't know if they would. This is where it gets crazy. If I want to cosine over sine. Okay. This is where this gets a little fuzzy. I promise you this will get better later. So this cancels, right? You're good with that? Now, I think if I looked at my notes last year, I think I keep going. Don't get too scared about this. Because I don't know if I left this as an answer, which seems slightly less, but I could continue. And I promise you this will get better. You'll know when to stop. Of course, speaking of stopping, my pen stopped. Because I pulled out a tan. And that's a minus right there, isn't it? Oh, this is a plus one. Sorry, I got you. You're right. What the heck is going on? All right. Anyway, you're right. Okay, here's what I was gonna do next. Isn't tan on the bottom the same as cotan on the top? So, and you got to get used to doing that. That's why the fraction left. So I don't want to have to write this as sine plus one, sine of theta plus one, times separately on the outside 1 over tan. I want you to be able to understand that tan on the bottom becomes cotan on the top. Now, again, put a little star here. Don't get scared. If you feel good about this, and you should, to be honest, then you're on the right path. But this is like what you're eventually going to have to do when things are a little bit clearer. How far do I have to go? Just remember I said that. And I don't want to get into it because of our time. And isn't this cosine over sine? Now, I'm not even sure this is even better. And I'm not even sure if I did this last year. Because what happens when I take those two and multiply them now? Who cancels? Sine. And then the other one doesn't. So when I hit this here, my final answer would be, hopefully you know cosine is left over. And then I'm going to turn this back into cotangent. And what you did is you got rid of fractions completely too, which everyone hates, right? Don't we all hate fractions? Okay, so usually that's like the simplest form at the end. But I would argue that maybe on a test, this could be the end too. It depends, and I'll show you when we keep going on this stuff in the next couple days, how you know when to stop. And I just want you to think about that as we're going. So that's why this one's really stupid. If we would have done this one, it doesn't really simplify when I do stuff. It doesn't. It's just, so why did we even do it is my point. But this is clear and cut. What's 1 minus sine to the fourth? Difference of, say it, 2 squares. And then, you know what we're going to do? We could do one of two things. You know what would be smart? What would be smart is actually changing the bottom because I see the top. I know this is the reverse of simplifying, but what did you learn on the other side? What cosine squared is equal to? I literally wrote it. So you can do this. I think last year what I did is I left this as cosine squared, but then I changed this to cosine squared. And then it just took me an extra step. They were still going to cancel no matter what. You see what I'm saying? Okay. And then actually this one's done because don't make up a Pythagorean identity. 1 minus sine squared is cosine squared. 1 plus sine squared is not. So that doesn't simplify. That's not one of the Pythagorean identities that turns into something else. Okay? You have to admit that's simpler, right? Don't you agree? These are the ones that make sense when it does get reduced. People are packing. All right, and then how do you do this? Packing up their stuff, I mean. And then there goes my pen again. I love it. What time is it? What time do we have? 19. All right, what do I do with this? Starts with an F. I have no time for this. Wrong! Wrong factor. It's a 4-letter F word. Careful. Foil. No, watch it. Foil. Okay. So where do you? Now I'm getting attacked by a student. What? Oh my gosh, these phones. All right. I wish you had a. You would have been on. If I had the camera on, you would have been in the camera. So sine of theta plus cosine theta. Sine of theta plus cosine theta. They left now. Should we talk about them? I'm just kidding. You don't even have a thing on anymore. How are you leaving? Do you still have this
I
pass?
do still have it's for 4 weeks.
Great. Show up late, leave early. Oh, wait, you're not one of the late
I'll
ones.
show up late.
Oh, that's okay. Sine squared, sine cosine, cosine squared. So sine squared plus sine cosine, that's 2 sine cosines. And then cosine times cosine is cosine squared. Now you want to get nuts? Let's get nuts. You've got to be able to do what I'm doing here. By the way, if you do this, you're gone. What kind of error is this? What did I? Yes! It's a 6 over 5 equals 2 error. When you take part of a sum, but watch what happens in this anyway, and cancel it with another part of the denominator, and then lo and behold, 1 plus 1 over 1 is 2. 2 equals 6 over 5. Is that true or false? So it's false what I did there, but luckily something nice does happen here. So avoid, this is where your true fractional challenge really comes out. This is why I've been trying to teach fractions all year long. Because when we simplify, we can't do those silly fractional errors. But look on your page before, flip it over. What is sine plus cosine squared equal to? What is sine plus cosine squared equal to? 1, not -1. This is how you got to do this. You got to kind of locate the portions of identities that you see and then replace them with or substitute. So isn't sine squared plus cosine squared equal to 1, right? Right? And then plus 2 sine theta, cosine theta, and then minus 1. And then what happens with the 1's up in the top? Now I can go ahead and cancel. So you would have got lucky if you canceled early. Like I showed you, the 6 over 5 equals 2 error. So I cannot overemphasize, this is when your true fractional skills are going to be challenged. All right? Okay, and now I could, what? What's the final answer? 1/2. 2 over 4 is 1 over 2, and you're gone because these are times. Whenever it's multiplication only, you can cancel everything and everything and anything that works. Okay, so we made it. We're done.